So what is the state machine for the APB? There are three states. One is idle state, then setup state, then assess state. In the idle state, if master sends P select X is equal to 1, then corresponding slave will go to setup state. In the setup state, master should send PW data, P address, and P write signal. If P write is equal to 0, then it will go to read state. If it is equal to 1, 1 means 0 means read, 1 means write. Next clock cycle, there is no condition, just next clock cycle. Slave will go to assess state. In the assess state, slave will check if P rate is equal to 1, then whether it is write or read operation completed. Okay, so now what happens if P rate is equal to 0? P rate is equal to 0 means slave is busy. The slave is busy means master will wait for slave. It won't change any value. It won't change any data. Okay. So now if one read and write operation is completed, next what? Next, if P select X is equal to 1, then master wants to do further communication. So it will go to setup state. Setup state. If P select X is equal to 0, then master don't want to do any communication. So slave will go to idle state. Just you have to write these things in your FSM. So understood the FSM for the APB, Amog? Hello? Both of you understood it or not? Yeah, hello?
Yes, ma'am.
Okay. So now same thing. So first I have declared all the signals, clock, reset n, then P address, this is the address, PW data, P write if it is equal to 1, then write operation, if it is equal to 0, then read operation. PW data, it is the write data. P address, it is the write address. P select X, if it is equal to 1, then the slave is selected. P enable, it has no work, but in the setup state, its value must be 0. In the assess state, its value must be 1. This is according to your protocol. Now this P ready signal, if it is equal to 1, then slave is ready. If it is equal to 0, then slave is busy. So PR data, this is the read data. This is all the signals corresponding to your APB. Next, I have taken actually 3 states are there, but extra 1 state I have taken, that is the wait state. In the wait state, it will not do anything. It will just wait for the signal. Okay. You can make these 2 states as 1 state also, or you can take different states. And here I have taken one memory to store the data, because data will be written and data will be read. So I need a memory to store it. Okay. So now this is the normal FSM. Always at the rate passage of clock and negate of reset. Okay, reset, and it is the active flow reset according to your protocol. So if it is equal to 0, then it is idle state. If it is equal to not 0, then it will go to next state. So this is the common for like almost all FSM. You have to write this kind of thing. Then next state logic. So next state logic is totally written depending on this. So first, if P select is equal to 1, then slave will go to set of state. So see, first slave is in idle state. So if P select x is equal to 1, then next state is equal to setup, else next state is equal to idle. Now in the setup state, there is no condition. In the setup state, slave should go to next SS state. In the next clock cycle, slave will go to SS state. There is no condition required. So once it go to setup state, next it will go to SS state. So in the SS state, it will check whether P rate is equal to 1 or 0. If P rate is equal to 0, then it will go to wait state. It will go to wait state. If P rate is equal to 1, then one transaction is completed. Next, it will check whether P select x is equal to 1 or 0. If P select x is equal to 1, then it will go to setup state. If P select x is equal to 0, then it will go to idle state. So 0 means it will go to idle state, 1 means it will go to setup state. In the wait state, what will do? It will do nothing. It will just check this P ready signal. If it is equal to 1, then it will go to here. If it is equal to 0, then it will remain in wait state. Why I have taken a different wait state? Because in the wait state, no signal should change. P enable should be continuously 1, P select X and P ready, all the signals should be constant. So I have taken another state. So you can make it here also. It is possible. Okay, you can make these things right here also, not a problem. Default state is the idle state. Okay, so next is state written. So now I have written how to change the state. Next, how can I get this R data? Means this output PR data. So PR data I will get once I will write into the slave, then I will read from corresponding address, then I will get the PR data. So I have taken one slave. This is simple single port RAM. This is my slave. Okay, so passage of clock. If your reset n is equal to 0, then PR data is equal to 0. Else begin. See, if present state is equal to SS. So in the SS state only you can write or read data, not in setup state or not in SS wait state. So in the SS state, if present state is equal to SS and P write is equal to 1, then it is going to write the data. If P write is equal to 0, then it is going to read the data. And here these two things, actually this P ready signal, it will come from this slave. Here intentionally I have made it 1 for some time, then 0 for some time, then again 1 to check whether it is working properly or not. Okay, so these things it is not required. You can make permanently P ready equal to 1 also. That will be correct, not a problem. So this is all about your APB code. So I'm just explaining these things. Okay, you just go through this code once. If you don't understand, then next class again I will explain. Then we will go to test bench. And Amok, please go through this document. I have already explained. You just go through this document. Its link also I have sent in the previous class. Okay, Bunny, you can send the PDF also in the share in the group. So just go through this APB. APB, it is an important protocol for freshers. So you should know it in very well, like how to write data, how to read data, particularly this waveform. Okay, and both of you do one thing. Once your project is completed, you have to present a slide to me. There, this waveform should be there. What are the pin configuration will be there? How you have written the code? How you are getting the code? All those things you will be explaining to me. So start preparing from today. First, this slide. Prepare this slide. If you are understanding these things, then easily you can understand this code. Okay.
Yes, ma'am.
Okay. So Bunny, you also okay? Just to start. Have do you have any doubt like in the theory part?
Ma'am, I have designed a traffic controller, but
Okay.
there is some problem.
Share the code here.
And yes, ma'am. Mm, Ma'am, host disabled attendee screen sharing.
No, no, no. Share the code means you just copy paste the link in the chat box.
Acha, okay,
Hmm.
yes, ma'am.
Just here.
Yes, ma'am. Um, this is for control. And one more, I have designed a frequency measurement system for random clock. That also output is not coming. Ma'am, but here output is coming. But how to use the parameter, I'm not understanding. No,
Again,
not parameter, that define statement.
you have written by yourself all these codes.
Ma'am, in Samir Palnitkar book, after uh, the end of the behavioral modeling, this is the
Okay.
example, but I have understand and code by myself.
You have understood it or not?
Yes, ma'am.
Okay.
I have done this code without seeing. Both the code are different.
So you are getting some output.
Yes, ma'am. Ma'am,
One,
if
two, three,
X
zero.
is 0,
Hmm.
then the sensor will be sensing that in the countryside there will be no car. Okay.
Okay. Okay.
And after some delay, I have applied at the passage and I have problem at that passage. Ma'am, please open the code.
Hmm.
So, ma'am, in design down, there I have defined the FSM.
Huh.
Mm,
So what is your doubt exactly?
so, yes, ma'am. So, here in the line like 37, uh, in the book it is written repeat, and it is having tick define some delay too,
Okay.
and it is defined by define statement, but I
Hmm.
have used here parameter, and when I use that define statement it is giving some error, ma'am.
So you just show
So
me that error part. Here there is no error. You whatever you are saying, just write it and show to me. Then I can say whether what the mistakes you are doing.
Okay, okay, ठीक है मैम. Second one also I am
And one more
giving
thing,
the.
don't write always passage of clock, you write passage of reset. Don't mix age and level. It will be not synthesizable.
अच्छा. So ma'am, we don't have to write passage of clock at the
Huh,
rate.
huh, passage of clock, passage of reset, or you can just passage of clock is sufficient. In the state change, we don't need clock. I will look into that Samit
Okay.
Palatkar example and I will let you know okay, what are things here also. You should not mix those things. Means it is like you are doing mixing combinational and sequential part. That is not correct. Okay.
Yes, ma'am. Ma'am, the second code, ma'am, output is not coming. But design is not giving error, but output is wrong. I have to measure, ma'am, frequency of a random clock.
Okay. Frequency of a random clock. Then you have to 1 divided by time period.
So, ma'am, this count have to increment only once, and neg count will give the t off, and pause count have to give t on. And after
Okay.
that, ma'am, I have disabled this block, but it is giving output continuously and
Okay.
increasing the value.
Always set the rate passage of clock in begin pause forever pause count. Okay, in the name. Hmm. But here the block is not disabled, right? So it is continuously counting at every negate and it is counting whenever there is pause of positive of clock.
Hello.
Yeah, hello.
Yes, ma'am. Ma'am, that hashtag one, I thought it will be a counting means delay. So
No, no.
the least resolution would be of hashtag one.
Why
So,
you have written it inside forever?
ma'am, because ma'am, it has to repeat, ma'am,
No, in the
at
always block
every
only it is repeating, right?
one
That's why
nanosecond.
forever means it is keeping on counting after hash one, it keeps on counting. Here it was continuously counting, right? Because you have written forever. So whenever clock means once positive phase clock means forever it started counting 1, 2, 3, 4 like this. So next you want that in the negates it should be 1.
Acha.
So what you need like here it should start counting then it should be 0 or what?
Yes, ma'am. If clock in is at positive edge,
Hmm?
so it should start counting, and at the clock in, if a negate is appearing, then
Hmm.
pause count will be stopped, and
See,
after that
now
negate of clock in, neg count will be starting,
see that
and
is happening here.
as soon as pause it. Yes, ma'am.
That is happening here, right? You want these things or not? Here
Ma'am,
see.
after that first negate and after
Hmm.
first second passage, the
Hmm.
counting should be stop and it should be stable, so this
Okay,
neg count will
okay.
give
It
the
should not
t
go
of
like
time.
this, right? Or should
Yes,
just
ma'am.
count once, then it should stop. Okay, okay, I understood.
No, ma'am, not one, ma'am, it
Then,
should count the number of nanosecond, like,
okay.
so I have repeated in the forever loop, so I'm not able to. verify it and also design
Okay.
it properly.
Okay.
Some my friend has given us that doubt. So to design it, so
So
I
you
have
have
designed
written
but
this code
not
by
able to
yourself.
get the output.
Okay, okay. You just tell
Yes,
me.
ma'am.
You have designed it by yourself. All you want to know that count how many number of counts are like frequency, clock frequency.
Ma'am, suppose this clock in,
Hmm.
the positive, the plus 5 value of clock in there are how many 1 nanosecond. We have to count like that. So we
Okay, okay.
can count the number of nanosecond in clock in at t on
Hmm.
time. So it will give the t on time and it will be
Okay,
stored in positive count. And
okay.
same for off time.
Hmm.
Off time we will be calculating after the negate and we
Hmm.
will be incrementing after 1 nanosecond each.
Yes.
So how many nanosecond are there in t off?
Okay.
It will be given by neck count, and
Yes.
after that we add both the neck count and pause count. We
Okay.
will give the
So
time period.
after this one and this one, it should be zero, right? It should not count more, or it should go on counting.
No, ma'am, it should not be counting, and the value should be fixed, stable.
Okay. Uh,
So, ma'am, we have to use, ma'am, always statement. Oh, sorry, forever, because,
yeah,
ma'am,
yeah.
this
Okay, now I
pause count
understood.
will only increment in clock in the passage of clock in.
Hmm. 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 Hmm.
But we have to apply some condition like that. This pause count will only be executed when passage clock in. Ma'am, after this seventh line will be executed and
Hmm. You
eighth
have to
one
check why it is
is
not
going.
working.
Ma'am, the syntax is correct na that
Ha ha.
begin and all.
Syntax. Yes,
I have
yes.
disabled it.
Yes,
Ma'am, how
yes.
to
This the.
enable it once again another time? It
Okay,
cannot happen like that.
it can happen. I will let you know, but I will first have to check whether it is working in EDA playground that disable or enable part of thing or not.
I have wrote enable, but it is not a thing. I think it is a not keyword because it is coming in black color.
Okay.
It is not coming in
Okay.
purple color.
Let first clear this one, then I will tell you that enable and disable. Okay.
Yes, ma'am.
Where is the error? Passage clocking. going on counting. For switch of clock in means clock will go from 0 to 1.